we will challenge the code. So first thing is that you should not believe the design codes or the formulas written there or the equation that you have seen. So the design procedures, design principles or design things written in building codes or design codes, we have to forget them for a time being and go where did they come from. So we understand the basics behind development of those equations and not believe them because somebody wrote them. So we need to challenge everything. That's the first thing. We have to integrate, unify and generalize. So we have to integrate in such a way that we don't need to understand everything because we have no time. There's only one course. So we cannot go to the detailed design of column and beam and footing and stairs separately. We have to unify them into theories that can be applied to everything. Then after that, you can just look at a problem and you should be able to solve it. Main topics are going to be like this. Material behavior, so we will start with that. It's very important. Stress strain curve, section behavior, member behavior, then deep members, then joints, and so on. So this is the overall topics. You will get these slides. I will get the emails of all of you, and Mr. Salman will send you the link that you can download the presentations. So in my class, 0 paper. I will never expect you to submit anything in paper. Assignments all online. Everything will be online. So we don't use paper at all. You can use paper, but I will not use. Sustainable, yes. Yeah, we don't use paper. So these are some of the presentation the topics that we will cover. So what is the book? This is the book that we will use as the basis. It's written by me and one other person from AIT. You can pass it around. Take a look. This is available in library, or you may also get a soft copy. So we will use this book for mostly this book for this course. Prabhat is a PhD student here. He's also finished from here, so we wrote this. This is the second class that we start to use this book. Previous classes helped to write the book, and now you're going to use it. Now, what is this? Anybody knows about this one? What is this diagram called? Forget about what is written. What is the diagram called? Mind map. Mind map. Did you ever hear about mind map? Yes? Who? Oh, you. Who? Anybody else? Okay. You also. What is a mind map? Yes. Come in. What happened? Where are you? Why? How can they know and you don't know? Okay. You missed the best part. Oh. So why is this infusion that there is so far? Who said that? Dr. just said. Okay, I'll go and see him later.
No, he doesn't give the guarantee that he said if he comes, we take it.
No, okay, anyway, never mind. Okay, this looks better. Half the class is this. Anyway, so we'll come back to you in a moment. So, what is this? Okay, let me go back to the presentation because half the people are here. I will go very fast from what we discussed so far so that you don't miss. Okay, introduction. So we were talking about the importance of structural engineering. Very quickly, I will not spend too much time. We were talking about that structural engineering is very important, and I was asking everybody why you are here. And we were saying that everything that is built around you, we need structural engineers. We showed many buildings, and we said, okay, these were done by structural engineers in the old times. And I was asking them, what is this? The new people, what is this? Why is it named Eiffel Tower? Who was he?
I think he was an architect.
Yeah, structural engineer actually. They were designer. Okay, at least somebody knew about this one. Okay. And this one? Okay, good. So now you know that. So we were saying that all the important structures, all the important things in the world, they are done by structural engineers. So structural engineering is a very important field. That's what we are trying to say. I was telling them what are the new buildings coming up. What is this? The people who are saying a lot. This is Malay Bridge in France, for the world's tallest and longest cable stayed bridge. Okay, London Bridge. What is this structural system called? Okay, diagrade. It's called diagrade. Okay. What is this thing called? New. Old people do not apply. New people. What is this system called? What is the form? Name of this form? No. This form. I'm talking about this one. This is called hyperbolic paraboloid, right? So I was just telling other people that you people need to know more about what you are going to learn. We were talking about important structures like, no, this is, what is this? Where? Again, this is one of the structures which is not well designed. The designer of this structure is always blamed for designing it in the wrong way. Do you know why? No, of course not. This shell is very thick. It's almost a meter thick. It should be very thin. They use the wrong theory to design it. But anyway, it's now there. But the engineering community do not like the design because we think it is badly designed.
It's renowned.
It is renowned, yes. But it doesn't matter, it's good design. Okay, and then we were talking about that sports arenas, everything structure engineers do, nuclear power plants, electrical transmission towers. So we talked about, and please note down new people. This book, everybody should read, The Tower and the Bridge. So this book is very important. If you want to be a structural engineer, you must read it. And we were talking about what the structural engineers do, and the structural engineering profession, the different activities, and application of computers, and typical building, various components. Now this is more about the course. So we will be covering the reinforced concrete design of various parts of the building, including slabs, columns, beams, footings, and everything. But we will not study them individually. We will study the concepts behind them so that you can do them in a good way. This is the main content of this course, these 6 or 7 topics. And now we are going to start next time on material behavior, and we will see the importance of the material behavior. And I also mentioned that we will be studying concepts behind the design codes. Why a certain equation is like that. So we will challenge everything. Please do not believe everything that you have read so far. Forget about it. And I mentioned that this is the book that we are going to use for this course. And this is being passed around. It's in the library. You can take a look. Yes. No, we were saying, what is this? And when you entered, we were talking about this. What is this? We said it's mind map. What's a mind map? Anybody else knows what's a mind map? Mind map, yeah, you were saying something. Please, continue.
It's like critical thinking about the topic.
Correct. Very good. This is a critical thinking about any topic. So one thing that I would like you to do is that whenever we have any issues, anything, try to create a mind map of that problem. Then once you create that mind map, you will always remember, mostly you will remember, you will not forget. Because you have thought about every aspect and every angle, and you have created that, and you will not forget. So for example, if you want to remember this lecture or any topic, create a mind map before you sleep or whenever you can, maybe small. Okay, I learned about this one's related to that one's related to that one. Then you can cover the whole, and then you also know the relationship between them. You will then have that picture in your mind. So it is really, really good learning tool, an analytical tool, an understanding tool. So people try to solve the problems now, big problems, by using mind maps. So this is a mind map of structural engineering. This was prepared by one of the students in the previous class. This was an assignment that I gave to previous class, and all the mind maps that I showed you, they are prepared by the students from your senior students. So this is about structural engineering, how broad this. So one of the assignment was, tell me how structural engineering is applied. So this is, they're saying structural engineering applied in aviation, applied in humanity, how it is applied in humanity, it is applied in chemical engineering, how it is applied in chemical. So you can keep on going to infinity. The mind map can cover the entire knowledge. If somebody is smart enough and has enough time, they can create the mind map of the entire human knowledge, because each thing is connected, and you can keep on going forward, forward, forward until there is no end, right? So things, this internet is kind of a mind map. It's a web. It's just going everywhere. It's like a web. It's like a mind map. It just gives you all the connection from here, and you can keep on linking and doing that. So these are some other mind maps prepared by the class, different way, different software, different tools were used. Another mind map. So you can see it is represented in various ways. So you can choose any one of them. Different tools they used. There are so many apps, so many programs available on the internet that you can download for free, and then you can create your mind maps. Okay? This is another one. So you can see every mind map is different from the other because they all use different tools.